Hello everyone. Welcome to today's session. My name is Rachael Fernandaz, and I am a researcher and a PhD student. So, I'm a researcher based in Qatar, and I am a PhD student slash distance scholar who's doing a PhD from the University of Sussex in the UK. So, with today's session, we are going to be talking about the very basic concepts of machine learning, with a more specialized focus on how Google machine learning APIs can be used. So, if you're a beginner who's just interested in trying to get into machine learning, you don't really know what this is about, or if you have a business or a tech startup and you just want to use machine learning in your products, then I think this would be an ideal session for you. So let's get started. So before we look at what is machine learning and how we can use it, let us first try to understand if machine learning is something that we encounter in our day-to-day lives, if in fact we are using it every day, and how does it help us. So over here you can see that a woman is like buying something from a supermarket, and it says customers who bought this item also bought some other things. So well, this is basically sort of a recommendation system. So if you use YouTube, you can see like the recommended videos. If you use maybe like Amazon or some sort of a online shopping website, you always see the sort of related products at the bottom. So, well, these are all tailored to meet your specific interests. And so, yes, these use machine learning. Then, of course, it's also used in cybersecurity, where it is used to identify the different types of viruses or the different types of attacks that you can face. Then, of course, we have social media analytics. So now the advertisements that we see on social media are like very personalized and very targeted for a particular user. So yes, this also uses machine learning. We also find this in like financial services, like the stock prediction. And of course, we also use it for DNA analysis. So basically, yes, machine learning is very important and it's all around us. So these are just 5 of the applications I showed you, but there are so many more applications that you can use machine learning for. So now that we understood where we have seen machine learning, let us now try to sort of understand how we as humans actually learn stuff. So we actually learn things from past experiences. So if we are like taught something, then we sort of retain it, and that's how we remember things and apply it in future. But the machine actually has a different way of learning. So in this case, machines actually do what humans instruct them to do. So this is not just about teaching the machine ABCD or something just random, but basically teaching the machine how to analyze something. So, and also the machine is only as good as the instructor. So it all depends on how you are instructing your machine to work. So now that we've understood the differences between how a human and how a machine works, let us now try to understand what is machine learning. So as you can see, the quote says that it is the science of getting computers to act without being explicitly programmed. So well, let's look at this example to sort of understand it a bit more. So on the left, you have 3 images of an apple. So, and then you also tell the computer or the machine, well, hello machine, these are apples. So this is how we as kids would have also learned it, like some maybe our mom or teacher sat us down and told us that this was an apple. So similarly, we tell the machine the same thing, that these are apples, and then it sort of understands, well, this picture of an apple actually relates to, well, the textual word over there, which is apple. So the next thing that we would have done after we learned all these things was we all sat for an exam, right? So in this case, just like how we were evaluated based on our understanding, we can now go ahead and ask the machine, well, what is this new image? And then the machine takes its time and then it understands, well, it's an apple. So this is sort of the difference between the traditional programming and what we use today in machine learning. So with traditional programming, you would actually give the computers the data that you want to analyze, and you also give it a program. So the program is nothing but a set of instructions where you tell the machine how it should work on this program. And then it sort of does whatever you instructed it to do, and then it gives you the output. But now that we all know that humans are far more complex creatures than a machine. So we are trying to sort of bring in the pros of how the human mind works. So we just saw that humans actually learn from past experiences. So we're trying to bring in this particular quality of humans to integrate it within the machine. So now with machine learning, it sort of goes against the traditional programming principles where we where we give the machine, where we feed the machine with data and the output. So in our case, we showed the machine a picture of an apple, and we also told it, well, this is an apple. And the machine learning algorithm actually comes up with something which is the program. So it gives us the set or the procedure or the process that it followed to basically analyze this particular set of data. So another way of looking at this was in traditional programming, you would actually sit down the computer and tell it how to do something. Whereas in machine learning, which is the newer way of doing things, we don't tell it how to do. We just tell the computer what to do, and it comes back with the how to do something part of it. So now that we've seen that, let us now look at how do you teach the machine. So this is very simple. So let's say you have a bunch of apples and a bunch of mangoes. So how, as a human, how do you actually recognize the difference between apples and mangoes? So that's sort of straightforward, right? Because, well, you can take the color or you can take the shape. You can use a combination of these two features. So the color of an apple is red and the shape is circular. Whereas with the mango, it's more yellow in color. It's more of an oval shape. So, well, basically, this is how, as humans, we identify the differences. Now, but this is fine. This is textual. So just to make it a little more easier, let us look at two other different features that we can bring from these fruits that are numerical. So in this case, we have the height and weight of the two fruits. So we have apples and then we have mangoes. So the first two rows, of course, show apples and the last two rows show mangoes. And if you just have a quick look at the data, you can see that apples are much lesser in proportion when you compare them with mangoes. So let us first start off by plotting these data points on the very simple graph on the right-hand side. So just like a scatter plot. So let's go ahead and plot that. So we have the first row, second row, third row, and there we go with the fourth row. So now it's sort of very easy to see. We can draw a line through the two sets of data points over here. So anything that falls on the bottom side of this line, we can see that it's an apple, and anything that falls on the top or on the higher side of the line, it would be a mango. So now, of course, so this is fine. The machine was able to understand between just four different rows. So now let's see what happens when we give it a new row, which is an apple. So here it first plots the data, and it doesn't know whether it's an apple or a mango yet, which was why you could see that it started off with a purple color. So after it plots over here, the machine quickly recognizes, well, hey, this falls on the bottom part of the line. So of course, this has to be an apple. And so then it tells you, well, this is an apple. But of course, real life data does not really work like this, right? Because real life scenarios are much more complex than what we just saw. So in this case, let us take the example of apples and oranges. So over here, we will not be able to draw a straight line or anything over here to sort of show the boundary between the two fruits, right? Because apples and oranges are almost similar in their dimensions. So how are you going to be able to show the difference much? It's purely based on only their color, and just one feature is not good enough. So in this case, the machine learning model becomes a lot more complex. And at this point, it starts off even getting a little bit more complex for the human mind. And well, so what the model does is it looks at the data from a different dimension, and then it sort of slices through it. And now you can see that from this dimension, you can actually see that the points are one below the other in when they were sliced. So this is a much more complex example than the last one. So we've kept talking about the machine learning model or the machine learning algorithm, but we never really touched upon what this model looks like. So that's because the model is mostly a black box. So what do we mean by black box? So, well, we know that there's some sort of statistical procedures, mathematical equations that is basically the reasoning behind all of this. So even though we think that it looks like magic and there's some sort of genie in the box sort of thing happening, there's actually a reasoning behind all of this. But it's too complex for us to understand. So with simpler models, yes, you can understand what's going on. But as your data becomes more complex, your model becomes more complex as well. And then it sort of starts to get harder. So for now, so with the really complex models, like maybe a neural network or something of that sort, all that we can understand is that we feed data into it and it comes up with results. So to sort of sum up all the key things that we've seen, or the things that we could expect of a typical machine learning process, is that we would first start off by feeding the machine with the raw data with the labels. So let's say our raw data would just be pictures of apples and label them as this is an apple. So the next step would be to clean the data and then to sort of do some sort of feature processing. So what I mean by feature processing is we have to get some features out of the apple. So in our cases, we took the colors, we took the size, we took the height, we took the weight. So these are all the different features that we use for describing our data. So once we've done that, we move on to the third step, which is model selection. So there are like tens and thousands of algorithms that are available to us. So it's pretty difficult to identify which is the perfect model for us. And once, let's say, we have crossed this particular hurdle, we then have to do something called the parameter tuning, where we need to tune this particular model to meet our data set. So that's another obstacle. And finally, we go on to do model evaluation. So this is where this is something we mentioned before. So we said that just like how students take exams, we also need to sort of evaluate our model's understanding of the data. So the more better your model has understood the data, the more chances that it's going to do well with the newer set of data. And another thing that's worthwhile noting is that the data cleaning part seems to be a bigger icon. And this is because we would typically spend about 70% or 70 to 80% of our time doing data cleaning, which is basically the most important part of the ML process. And then followed by about 20 to 25% of our time would be spent on model selection. Now, if you're wondering why the data cleaning and the feature processing part is more important than the model selection, well, here's a quick infographic for you. So it just says garbage in, garbage out. So your analysis can only be as good as your data. So if the data that you feed to your model is going to be garbage, then there is no way your model will be able to outperform the garbageness of your data. So now let's move on to the next step. So, you can see that all of these things just tend to make a person really confused, especially someone who's new to machine learning. So the next step of this would be to utilize a pre-trained model. So with Google, we actually have a set of two different set of models. So on the left, you can see the custom machine learning models, and on the right, you can see the pre-trained machine learning models. So the custom ML models are mostly aimed at people who want to create their own models, who are into research and things like that. Whereas with pre-trained ML models, it's more than enough for someone who wants to quickly get started, to kind of understand the nuances. And of course, like if you have a business or a startup and you want quick solutions, then yes, this is a great way to go about it. So today in our session, we'll be focusing on the natural language API, but I will quickly run you through each of these machine learning models, and we'll just see an example. So the first API that we'll look at is the Vision API. So here you can see a picture of the Museum of Islamic Art in Qatar. And well, if you see it, it's not very apparent right away that the central entity of this particular photo is the Museum of Islamic Art, though it has like a bigger portion occupies a bigger portion in the picture, it's still a part of the skyline. So let's see what the Google API comes up with. So here you can see that it's correctly identified that it is in Doha. You can say that it identify that as a building, about all the other things that are there, what are the dominant colors in this picture, and of course, if it is a safe search. So if it contains any sort of explicit materials or if any sort of racy things. So, well, the Vision API can actually help you with that. The next thing that we will be looking at is the speech API. So let's say you have some sort of, you're learning from some sort of a website, so that is educational website, and you want to sort of also transcribe those things that is being spoken in the video, you want to write down them as text. So this is where the speech API can really help you out. So let's take a quick look at that. Welcome to the machine learning course. So, well, you could see over there, like whatever I spoke was immediately converted into text. So a great example or a use case of this particular API would be if you have like a podcast and you want to show people what you are talking about, then this is a great API to add to your website as well. The next one that we're looking at is the Jobs API. So the Jobs API has several functions within it, but there are two specific functions that I would like to show you. So the first thing is over here, you can see that this particular person is looking for position known as the server. So we know that in the IT side, we have something called the server or the Java side developer, whereas it could also mean like a barista. So in this case, the Jobs API sort of matches the concepts between the server side administrator and the barista. And also the next thing that it can actually quite intelligently do is the sort of acronym. So we know that people who post these sort of listings, they are very, very experienced in their field. So they are used to using acronyms in their job postings. So let's say you searched for HR, and maybe the API should not only just return these kind of posts where it says HR, but it should also be able to understand that you're talking about human resources, which is like the acronym, which is like which is like the acronym. So it should be able to relate both and show you that in the results as well. So that's what is happening here within this particular API. So the next thing is, of course, Video Intelligence API. Now, this is very similar to the Vision API, just that all the objects in this particular things are moving. And this particular GIF is from the Image Annotation Services, and you can see that they've done a very good job. You can see that it identifies all the people, and it shows like it tags all the people as people. It shows a car. It shows various things. All of that that it has identified in this particular video. So we're going on. So we'll just quickly move on to the hands-on session. And in today's hands-on session, we will look at three main functions from the natural language API. So the first one is called the sentiment analysis. So let's say you have some sort of a review website like Zomato. In that case, you can see if you want to understand if the customers are happy with your hotel or your restaurant, you can identify if they are having negative opinions or a neutral opinion or a positive opinion. And then, of course, we have text classification. So if you have a bunch of articles and you want to classify them between technology, sports, entertainment, actually the API supports about 700 different categories. You can go ahead and use this. And the third one that we'll be looking at today is entity analysis. So with entity analysis, any sort of subject that is central to your text is identified as an entity. So it could be people, it could be a product, it could be a location, it could be anything. So anything that is central to your text will be identified as an entity. So now let's quickly go on to the hands-on session and then come back. So let us quickly go through this. So here you can see that we already have four different files. And so the first thing that we're going to do is we're going to start and look at the library. And we will see if the library actually has this particular natural language API that is being enabled. So let's look at it. So yes, we can see the natural language API is there, and there is a sort of green tick on it. So next, what we will do is we will go and create an API key. So the API key is something that's going to help us with the API key is something that's going to help us with creating our own it's going to help us with the sort of authenticating ourselves. So in this case, we can create our own API, and that will sort of authenticate us to the API service. So what I'm going to do right now is I'm going to create a variable that will store this particular token, and we can use this particular API key again whenever we need it. So let us quickly go and see the contents of the first file, which is the CT1 file, which we will use for classifying the text. So let's open that. And here you can see that there is a very plain text that says, here is a modern twist to the classic caramel pudding. Just whisk the eggs until they are frothy. No, 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 no. So you can see that this particular text is referring to something that is talking about food. So what we should do next is let us quickly go and ask the API what it thinks of this particular text. So here's the curl command. And you can see that let's just paste it over here, and we'll use that. So here you can see that the API quickly identifies this as food, and within food category, it's drink and cooking, and within that, it integrates that as recipes and desserts. So, and it's pretty confident. It's like the confidence is a measure that lies between 0 and 1. It's pretty confident that this is talking about desserts, in particular the recipes of desserts. So that's for the caramel pudding. So the next thing that we will do is we will look at the next file, which is CT2. So let's see how the API classifies this. So here it says, I love programming. I just saw a video on machine learning. Should we learn how to create websites? Do you prefer JavaScript or Python? So that's great. So now let's go back to the API and check how this is being classified. So let's use the same URL. Let's just change the name of the file that we're using to CT2. And yeah, so over here, it has correctly classified this as computer and electronics. And it's pretty confident. It has a 0.6 confidence. And then also it has been classified as science or computer science. And it's about 0.59. So, well, that's again the correct way of categorizing this particular text. So the next thing that we will look at is the analyzing entities file. So let's first read what's there in this particular file before we go on. So over here, you can see that it says Joanne Rowling, who writes under the pen name J.K. Rowling and Robert Galbraith, is a British novelist and screenwriter who wrote the Harry Potter fantasy series. So let's just quickly see what the API has to say about this. So we know that Joanne Rowling is in fact the author of Harry Potter. So I'm just going to quickly change the name of my file. And of course, we also need to change the function because we're no longer classifying the text. We are going to be analyzing the entities that are present in this particular text. So yeah, so here we go. So from the response that we've received over here, we can see that it says it has correctly identified entities as Joanne Rowling. That's great. So, and she's a person. Yes, she's a person. Then we can also see that it sort of connects this particular thing to Joanne Rowling, which are all like different ways of calling Joanne Rowling. And the salience is 0.98. So that's a good measure as well. The next thing that so the salience is basically a measure of how central this particular subject is to the text. So it has identified Joanne Rowling is pretty, it's like pretty important to this text. Then, of course, it goes on to identify Robert Galbraith, which are all like different pen names that she writes under. And scrolling down, We can see that it has also identified pen names. It doesn't really know what to categorize it as, but it has identified that is also central to our text. Then let's scroll on more. And so JK is being identified as a person. British as a location, yes, that's almost right. It's a nationality, but well, it's a location. Fantasy series as a work of art, and of course, Harry Potter as a work of art, which is correct. And finally, screenwriter as a person. It basically talks about the position of or the role that a person plays. So the next thing we're going to do is we're going to look at the contents of the analyze entity sentiment file. And this is simple. It just says, I like the sushi, but the service was terrible. So let's say this is like a typical review that's left on Zomato or any sort of food site. So now let us quickly go and ask the API what it thinks of this particular text. So for this particular thing, we will use the same natural language API, but with a different function again, and it's called the analyze entity sentiment. So let me quickly type that. And yeah, so here we have the results for this particular thing. And you can see that it's quickly identified sushi and service as the particular entities. So sushi was one, service is the other. And you can see that it's currently identified sushi as a particular type of consumer good and service as another. So the score and magnitude are like two different measures that is given to our text. So the score is basically a number that lies between -1 to +1. So if you have more of a negative sentiment, it would lie in -1. If it is a positive, it would go to +1. And if you have more of a neutral opinion, it's going to stay at 0. And the magnitude is basically how strongly you have expressed this emotion, be it a positive or be it negative. So over here, you can actually see that in this case, we did not express our opinions very strongly. So, and magnitude actually falls in the range of 0 to infinity. So let's say we used much more stronger language, or we used a more number of lines to sort of talk about this, then yes, we will have a bigger magnitude, a score for magnitude. And finally, if you remember, we said that the service was terrible. But we liked the sushi. So now let's go down and scroll down to see how we placed, how service was rated. So let's quickly go down. So over here, you can see that the score that was given was -0.9, because of course we said the service was terrible, so that's a negative thing. Whereas on the other hand, the magnitude is again at 0.9, because like I said, we did not really use strong language to sort of express how we felt about it. We just said it was terrible and we left it at that. So for if we had used more text, more number of lines to express a sentiment, then of course this would be a much bigger number. So let us quickly go back. Before we sort of end the session over here, I would like to invite all of you to check out the Quick Labs. So with Quick Labs, actually, you have all of these APIs that are sort of explained in detail. You can play with them, and that is like a sort of guided tutorial to help you go through the entire process. Two other things before we end the session. If you are looking for the attendance certificate, please fill the feedback form that should be available shortly. And also, please join in the weekly challenges that Meena Digital Days is sort of organizing. So you can quickly go over here and you can see that there are so many quests that you can use. So if you can solve any 6 of the quests, you can win a box of goodies. And if you can solve up to 12, then yes, you can win a Google Home Mini. Yeah, that's it from my side. Thank you so much. If you have any questions, I would be happy to answer them now. Okay, great. Thank you so much.